Today, we're diving into the architectural backbone of pretty much any great piece of software, system design. Think of it as the master blueprint that turns a really cool idea into something that actually works.
So let's start with a really big question. It's one that every developer, every project manager, really everyone has to ask. How do you build something that's complex and powerful, something that can scale up and not just, collapse under its own weight? The answer is you start with a blueprint. Simple as that. You would never ever build a skyscraper without a detailed plan, and building software is really no different. You absolutely need that well thought out plan before anyone writes a single line of code. And that plan? That's system design. Okay, so let's get a little more specific. System design is a key phase in what's called the software development lifecycle, or SDLC. And the SDLC is basically just a structured roadmap for building software. So after you've figured out what the user needs, system design is where you translate all those needs into a technical plan. And this is the fundamental shift right here. We're not asking what the system should do anymore. We're now defining exactly how it's going to get it done. It's the bridge that takes us from those abstract ideas to a concrete plan of action for the developers. Now, the design process itself is split into two really big parts. You've got the high-level idea on one hand and the real-world implementation on the other. Let's break that down. First up, you have logical design. This is the conceptual part. You're mapping out the flow of data, the inputs, the outputs. The key thing here is that it's completely technology agnostic. Then you have physical design, and this is where it gets real. This is where you actually choose the specific database, the servers, the programming languages. And separating these two is so important because it means you can change the underlying technology later without having to redesign all of your core business logic. Here's a perfect example to make it crystal clear. The logical design states a requirement. Customer data needs to be secure. It's the what. The physical design then comes in with a specific solution. Okay, we're going to use a PostgreSQL database hosted on a secure cloud server. That's the how. So how do we actually create this blueprint? Well, it's not just one single step. It's a whole series of focused activities that build on each other to create a complete picture of the system. The first few steps are all about the user's experience. First, input design. How do people get information into the system? Like filling out a form. Next, output design. How do they get information out? Think of generating a report. And finally, interface design. How do they interact with the whole thing? This is all about making the screens clean, intuitive, and just easy to use. Okay, now we go a little deeper, kind of behind the scenes. Process design maps out all the internal logic that makes everything tick. Database design is absolutely crucial. It organizes how all the information is stored and connected. Then system architecture defines the high-level structure. Are we building one giant application or breaking it into smaller, independent services? And finally, security design wraps everything in a protective layer, planning for access control and data privacy from the very beginning.
Real architects don't just write descriptions, they draw actual blueprints. In system design, we have our own set of specialized tools to help visualize every part of the plan. This makes sure the entire team is on the same page.
Let's look at a few of the key tools. You've got entity relationship diagrams, or ERDs, which help us map out the database. Then there are flowcharts for showing step-by-step logic. UML, that's the Unified Modeling Language, gives us a standard way to model the system from lots of different angles. And then there's prototyping, which honestly is one of the most powerful tools we have. Yeah, prototyping is all about making the abstract feel real. It's where you create mockups, sample screens that you can click through even if they're not functional yet. This lets everybody, users, stakeholders, actually see and feel what the final product is going to be like. And getting that kind of feedback before you start coding is, well, it's invaluable. So, why go through all this trouble? Why is this so important? Because a good design isn't just helpful, it is the absolute foundation for a successful project. A solid design is the definitive guide for the developers. It helps make sure the system is efficient and reliable. But maybe most importantly, it lets you spot potential disasters while they're still just ideas on a whiteboard, not expensive mistakes buried in thousands of lines of code. It also makes the system way easier to grow and maintain down the line. And it just keeps everyone speaking the same language. So, the end result of all this work, all these diagrams and decisions, is one single comprehensive document. This is called the System Design Document, or SDD. It's got everything: the architecture, the database plans, the mockups, the whole shebang.
And ultimately, this whole process, this huge document, it really all boils down to one powerful idea. One blueprint. This one document, the SDD, becomes the single source of truth for the entire project. It's what aligns the analysts who gathered the requirements, the designers who made the plan, and the programmers who will actually build the thing. It prevents chaos, it reduces errors, and it turns a really complex process into a structured, coordinated effort. But here's the thing. A perfect blueprint is completely useless if the builders can't read it. So that leaves us with a final question to think about. What do you think is the biggest challenge in making a design that everyone can actually understand and follow? Something to chew on? Thanks for tuning in.